Good morning, everyone. I am fine. How are you? I hope you will be fine. Welcome back in my channel, Dr.Satendra Kumar. Dear friends, if you want this type of videos related to mathematics for higher level, then you need to subscribe, share and like my videos and my channel. Today, we will discuss some problem based on Gram-Schmidt orthogonalization process. Now, problem number first. Let VR is n. Let VR is n inner product space of all polynomials of degree lesser equal to and inner product is defined as Px inner product with Qx equal integral -1 to +1 Px into Qx dx. Full stop. Then apply Gram-Schmidt process to obtain an orthonormal basis for usual basis set S equal 1, x square for VR. Now repeat the question. VR is an inner product space of all polynomial of degree lesser equal to 2 and inner product is defined as Px inner product with Qx is equal to integral limit -1 to +1 Px Qx dx. Then apply Gram-Schmidt process to obtain an orthonormal basis for usual basis set S equal 1 to 1x, x square for VR. Now there is given usual basis set. This is the most important thing. Let usual basis set element can be considered u1 is equal to 1, u2 equal to x and u3 equal to x square, and v1, v2, v3 is an orthogonal set and a set w1, w2, w3 is an orthonormal set. Orthonormal set where w1 equal to v1 upon v1 norm and w2 is equal to v2 upon v2 norm, w3 is equal to v3 upon v3 norm. Okay. the main object here to determine first V1, V2, V3 is orthogonal and W1, W2, W3 are orthonormal side. Then by Gram-Schmidt process, V1 equal to U1, comma V2 equal to U2 minus U2 inner product V1 into V1 upon V1 norm square, and V3 is equal to U3 minus U3 inner product with V1 into V1 upon V1 norm square minus U3 inner product with V2 into V2 upon V2 norm square. But U1 is 1, that is V1 is equal to U1 equal to 1. Now V1 norm square is equal to V1 inner product with V1 can be written as minus 1, 2 plus 1. Now Px into Qx, that is both are 1 into 1 into dx, this is equal to x limit minus 1 2 plus 1, the value of V1 norm square is equal to 2. Now inner product U2 with V1 can be written as, for V2 minus 1 2 plus 1, the value of U2 x, value of V1 is equal to 1 dx, this is equal to 0. Now we can say, after putting the value of inner product U2 V1 in this equation, then we get V2 is equal to U2 equal to x. Okay. Now V2 norm square is equal to V2 inner product with V2, this is equal to integral minus 1 2 plus 1 x into x dx, this is equal to 2 times limit 0 to 1 x square dx, this is equal to 2 x cube upon 3 limit 0 to 1. Now the value of V2 norm square is equal to 2 by 3. Now we can calculate U1 inner product with V1 and U3 inner product with V1 and U3 inner product with V2 for the value of V3. That is inner product U3 between V1 can be written as, this is equal minus 1 2 plus 1, value of U3 is x square, value of V1 equal to 1, this is equal to 2 times limit 0 to 1 x square dx, this is equal to 2 by 3 limit 0 to 1, that is 2 by 3. Okay. Similarly inner product with U3 with V2, this is equal to integral minus 1 2 plus 1, value of U3 x square, value of V2 is equal to x dx, this is odd function, the value of this is equal to 0 always. Okay. Now we can put the value of U3 V1 and inner product of U3 V2 in this equation, then we get V3 equal to U3, that is value of x square minus 2 by 3 value of V1 is equal to 1 and upon V1 norm square is equal to 2, this equal x square minus 1 upon 3. That is, we can say V3 is equal to 3x square minus 1 upon 3. Okay, student? This is the V2, this is equal to V1. Now, value of V3 norm square equal V3 inner product with V3. This is equal to integral limit 0 to 1. Value of V3 3x square minus 1 upon 3 into 3x square minus 1 upon 3 dx. This is equal to 2 by 9 integral limit 0 to 1 3x square minus 1 whole square dx. Now we can explain whole square 9x to the power 4 minus 6x square plus 1 into dx. This is equal to 2 by 3 9 by 5 x to the power 5 minus 6x cube upon 3 plus x limit 0 to 1. Okay, student? This is equal to 2 by 9 9 by 5 minus 2 plus 1. This is equal to 8 upon 45. That is V3 norm equal to 2 under root 2 upon 3 under root 5. Okay. Hence, orthonormal basis can be written as W1 is equal to V1 upon value of V1 is equal to 1 upon V1 norm. This is equal to 1 upon under root 2 V1 norm square is equal to 2. That is W2 is equal to V2 upon now V2 x upon V2 norm square. The value of V2 norm square is equal to this, that is under root 2 by 3. Now V3 is equal to W3 is equal to V3 3x square minus 1 upon 3 upon norm of this 2 under root 2 upon 3 under root 5. Okay. Now we can simplify. Then we get basis set is equal to 1 upon under root 2 comma under root 3 by 2x comma 3x square minus 1 under root 5 upon 2 under root 2. Okay, student? This is the basis normal set. Question number 2. If VR is an inner product space, if VR is an inner product space of all polynomials of degree less or equal to 2 and inner product is defined as fx inner product with gx equal integral limit 0 to 1 fx into gx dx, okay, and fx equal to x square plus x minus 4 and gx equal x minus 1, then find inner product of fx with gx and gx norm also. Now solution: fx inner product with gx equal to integral limit 0 to 1. Value of x is fx, x square plus x minus 4. The value of gx, x minus 1 dx. Okay. Now multiply this, we get integral limit 0 to 1 x to the power 3 plus x square minus 4x minus x square minus x plus 4 dx. Now x square cancel by this 4. This is equal to integral limit 0 to 1 x to the power 3. Now minus 5x plus 4 dx. We can integrate x to the power 4 upon 4 minus f 5x square upon 2 plus 4x limit 0 to 1. This is equal to 1 upon 4 minus 5 by 2 plus 4. After putting, the value will be 0. Okay. This is equal to 7 by 4. Now gx norm square can be written as gx inner product with gx. Okay. This is equal to integral limit 0 to 1 value of gx x1 into x1, that is whole square dx. This is equal to x minus 1 ka whole cube upon 3 limit 0 to 1. This is equal to 1 by 3 only. That is gx norm equal to 1 upon under root 3. Okay. Now next problem, that is question number 3rd. Find an orthonormal basis. Find an orthonormal basis of the subspace W of V3C spanned by U1 is equal to 1, 0, I, U2 equal 2, 1, 1 plus I. Answer. Now repeat the question. Find an orthonormal basis of the subspace W of V3C spanned by U1 and U2. The value of U1 1, 0, I, and value of U2 2, 1, 1 plus I. Now solution is let us consider a set B, U1 and U2. Since W is spanned by, U1, U2, therefore LB, that is linear span, B is equal to W. Again, since neither of these U1 is a scalar multiple of the other, therefore B is a linearly independent set, that is B is a basis of W. Now we have to make this basis an orthonormal basis by Gram-Schmidt process. V1 is equal to U1 and V2 is equal to U2 minus inner product of U2 with V1 into V1 upon V1 norm square. That is V1 is equal to U1. Now U1 is equal to 1, 0, I. Now V1 norm square, this is equal to V1 inner product with V1. This is equal to 1, 0, I. Inner product with 1, 0, I. This is equal to 1 plus 1 into 1 bar plus 0 into 0 bar plus I into I bar. This is equal to 1 plus 1. This is equal to 2. Okay? That is V1 norm is equal to under root 2. Now for V2, we can calculate inner product of U2 with V1 equal the value of V2 2, 1 plus I with V1 1, 0, I equal 2 into 1 bar plus 1 into 0 bar plus 1 plus I into I bar. Okay, this is equal to 2 plus 0 plus 1 upon I plus 1. This is equal to 3 minus I. That is V2 is equal to U2. Value of U2 2. Now putting the value of U2 inner product with V1 here. Now V2 is equal to U2 2 1 1 plus I minus u2 v1 3 minus I into v1, that is value of v1 1 comma 0 comma I upon v1 norm. v1 norm square, that is 2. Okay. Now after solving this is equal to 2 minus 3 minus I upon 2 comma 1 minus 1 upon 2 1 minus 0 comma 1 plus I minus 3I minus I square upon 2. Okay. This is equal to 1 plus I by 2 comma 1 comma minus 1 plus I minus 3I plus 1 upon 2. Okay. This is equal to 1 plus I upon 2 comma 1 comma 2 plus 2I minus 3I minus 1 upon 2. Okay. After simplification, 1 plus I upon 2 comma 1 comma 1 minus I upon 2. This is the value of v2. Now v2 norm square is equal to v2 inner product with v2 equal 1 plus I upon 2 comma 1 minus I upon 2 inner product with 1 plus I upon 2 comma 1 minus I upon 2. Okay. Now we can write 1 plus I upon 2 into 1 plus I upon 2 whole bar plus 1 into 1 bar plus 1 minus I upon 2 into 1 minus I upon 2 the whole bar. Okay. After simplification we get the value of this is equal to 2. Now v1 v2 norm is equal to under root 2. Okay. Therefore orthonormal set the value of w1 is equal to v1 upon v1 norm, w2 is equal to v2 upon v2 norm, or w3 is equal to v3 upon v3 norm. This is the orthonormal set. That is the value of this after calculation 1 comma 0 comma I upon under root 2. This is the value of v1 norm. Okay. Comma v2, the value of v2 is equal to this 1 plus I upon 1 plus I upon 2 comma 1 minus I upon 2 upon v2 norm, that is divided by under root 2. Okay student, this is the complete solution. Now repeat here, orthonormal set is equal to w1 is equal to v1 upon v1 norm, comma w2 is equal to v2 upon v2 norm, w3 is equal to v3 upon v3 norm, that is value of v1 v1 is equal to 1 comma 0 comma I, and now v1 all under root 2. Now value of v2 is equal to 1 plus I upon 2 comma 1 minus I upon under root 2. Now value of v2 now is equal to under root 2. That is w2 is equal to here this upon under root 2. Now there is no v3 here. Therefore, in the set of orthonormal set, there are two elements only, w1 and w2. Okay.